Since much of what we start with in a pre-calculus course is a review of stuff from Algebra 2, which is a good thing, I am going to be covering what are considered to be the most important concepts from the sections in Chapter 1. So you can always refer back to the book and their examples. I am going to do just the important topics, the ones that pop up over and over again in our course. So, the most important stuff from Section 1.1 on relations and functions are being able to identify domain range and if a relation is a function. Remember that a relation is a set of ordered pairs. This is a set of ordered pairs in problem A. There are 3 ordered pairs. They're in the little squiggly lines that we call braces, so we call that a set. Relations aren't always written in this format. Relations can be given as a set of ordered pairs. They can be given as a graph. If I were to graph these 3 ordered pairs, I would not connect the dots. I know you want to, but you don't. The only time we connect the dots is if we're given an equation, which is also a relation, and may or may not be a function. Domain referred to the x-coordinates in the set of ordered pairs. Now, we're starting with a simplistic case. So the domain is going to be -3, 4, and 2. Why? Because those are the x-coordinates. We usually write them in braces, and we write them in order from least to greatest. The range are the y-coordinates in the set, also known as the outputs. The domain is also known as the inputs. The outputs are 0, -2, and -6. -6, -2, 0 would be in order from least to greatest. Is this relation a function? A relation is a function if none of the x values repeat. That means there aren't more than one ordered pair with the same input. Well, since all 3 of those numbers I circled are different, this is a function. In the next one, in these 4 ordered pairs, the domain would be 4, 4, 9, -9. What do you do if a number repeats? Well, we traditionally don't write it twice. I mean, if you do, I'm not marking it wrong, but if you were looking up, did I do this right, and you were checking answers in the back of the book, they're not going to write it twice. So, we're going to write this as -9, 4, +9. The range is going to be -2, 2, -3, 3. So, -3, -2, 2, 3 would be in order from least to greatest. Last question, is it a function? It is a function if and only if none of the inputs repeat itself. There are 2 ordered pairs with an input of 4, therefore this is not a function. It's still a relation, but it's not a function. Another way we learned to determine if a relation is a function or not was by looking at graphs and using something called the vertical line test. So you would take the side of your idea or a ruler or something with a straight line, and you would place that vertical line anywhere on the graph. So if I put the vertical line here on graph A, my vertical line only hits the graph once. How about if instead I move it over here? Well, my vertical line only hits once. Remember that you can't see the whole graph, but it goes up forever both these cases. It really doesn't matter where I move that vertical line. It always hits the graph in only one location. Therefore, it's a function. Remember, this is a quadratic because it's a parabola, and it looks like it's probably the equation y equals x squared minus 2, because it's the graph of the parent function x squared that's been shifted down 2 units. Let's look at graph B. I'm not sure what the equation is. I'm not going to worry about it. I can figure it out, but I'm not going to worry about you figuring it out. So if I put my vertical line over here, it doesn't hit the graph at all. Okay, that's fine. What happens if I put my vertical line here? I want you to notice that it hits the curve twice. If the vertical line hits the graph more than one time, it is not a function. So you can have a graph of an equation, but it's not necessarily a function. Function notation, where y is instead replaced by f of x, that's how we pronounce it, not f times x, it's f of x. This was just a substitution. We run across this all the time. It's just that important. Not everything is as simple as problem A, though. In problem A, it says find f of negative 2 if f of x is 4x cubed plus 6x squared plus 3x. This problem is just as simple as replacing all the x's with a negative 2. And I also want you to notice that when I do my substitution, I plug in that number in parentheses. I do that on purpose. With a graphing calculator, it's very simple. You plug this expression in verbatim, you hit enter, and the calculator spits out the answer. Otherwise, if you don't have a graphing calculator or a two-line function calculator, you got to go back and use your order of operations. For the sake of argument, since this is a review, I'm going to do the order of operations. The order of operations say to do parentheses or grouping symbols first. Inside the parentheses, there are no operations, so that order's gone. The next order in order of operations are exponents and radicals. Sometimes we forget that radicals go with exponents, but I see some exponents, so I'm going to evaluate this and this. Negative 2 to the third power is negative 8. Anytime you raise a negative number to an odd power, you always get a negative. If you raise a negative number to an even power, you always get a positive. So be careful. After exponents is multiplication and division from left to right. So I'm going to multiply, multiply, multiply. I'm going to get negative 32 plus 24 minus 6. And the last order in order of operations is addition and subtraction from left to right. So negative 32 plus 24 is going to be negative 8. And then negative 8 minus 6 is negative 14. B is a little more difficult, but B is a pre-calculus problem. So you guys like if you can just plug a number into an expression, because you can just pop it into the calculator spits out the answer. But what happens in B when you can't put it in your calculator? Well, you gotta do some algebra. So to find f of g plus 1, when f of x is x squared minus 2x plus 1, everywhere I see an x, I'm going to replace it with g plus 1. Look at how I'm doing this. One of the most common mistakes that I find students doing when they do substitution is they don't replace the x. They know to plug the g plus 1 in, and then all of a sudden the x stays in the expression. The x is getting replaced. That means it goes away. All right. I can't add g plus 1 and get a different answer because that's a simplified expression. So then I go to the next order in order of operations, which is exponents. I love this one. A lot of you will get it wrong. I'm not saying that to be mean. I'm saying that because you want the problem to be simpler than it is. Don't worry. The honors students make the exact same mistake. G plus 1, when you square it, is not g squared plus 1 squared. It is not. Unfortunately, you have to do this. Remember that squaring means multiplying by itself, and then you have to distribute, or some of you may know it as FOIL. It depends on what teacher you had. So you would get g squared plus 1g plus 1g plus 1. Remember, 1 times 1 is 1, not 2. The middle terms are like terms, so they simplify. G plus g is 2g. All right. I haven't done anything with the rest of the expression, which is why I just brought it down. Now that I have evaluated g plus 1 squared, now I can finish the problem off. I can distribute over here. G squared plus 2g plus 1 minus 2g minus 2. And then I will combine like terms. Oops, sorry. So there's nothing to combine with g squared. The terms with g's are 2g and negative 2g, which are opposites, which means they cancel. And then 1 minus 2 is negative 1, and negative 1 plus 1 is 0. So it turns out the final answer is g squared. Last but not least, determining the domain of each function. We spent a lot of time doing this in Algebra 2. Now we're going to learn some other things in pre-calculus, but to start off with, in Algebra 2, we ran across 2 issues when dealing with domain. The 2 restrictions on the domain of an expression or function were 1, if you had a fraction, 0 could not be in the denominator because you can't divide by 0. The other restriction we ran across is that radicals must produce positive results. You can't square root something and get a negative unless you're working in the imaginary number system, but we're not. Right now we're working in the real number system. So, in problem A, I don't even care about the numerator. I only care about the denominator and the fact that the denominator can't equal 0. So really what I'm doing is I'm solving x minus 4 cannot equal 0. You solve this like you solve any other algebra equation. X cannot equal 4. So we say that the domain is x can be every real number in the world except for 4. Because if it's 4, it makes the denominator 0. It's called a restriction on the domain. In B, the square root of x plus 3. The portion that's under the radical has to be greater than or equal to 0. That's another way of saying positive. Because if it's less than 0, then you're trying to take the square root of a negative, which you can't do. Remember, you can take the square root of 0. If you're unsure of that comment, please plug 0 and then hit the square root key on your calculator. It will give you 0 and not an error message. You solve inequalities like you solve any other equation, so x must be greater than or equal to negative 3. Otherwise, the domain doesn't exist. Okay, what if I have a fraction and I have a radical? Well, not only can this not equal 0, but it also has to be greater than or equal to 0. Well, it can't be greater than or equal to 0 because we just said that it can't equal 0. So because it's in the denominator, instead we're just going to do this. Notice the missing line under the inequality symbol. Remember that line under the inequality symbol means or equal to. But we just said that x can't equal 0, so instead we're just going to answer the inequality x minus 1 greater than 0. X has to be greater than 1. Not greater than or equal to, just greater than. And in the last one, I gave a tricky one. The reason I did that is because I want to do a quick review of factoring, which is another F word that all math students love. Factor, fraction, function. We've got some pretty awesome F words. All right, so in order to find the domain, you must first factor. And the way we went about factoring simple trinomials is we look for 2 numbers that multiply together to give you the last term. But when you added those same 2 numbers, you got the middle coefficient. So what two numbers multiply to give you negative 2, but when you add them, you get negative 1? Well, they are negative 2 and positive 1. All right, so those cannot equal 0. In order to solve this, we're going to use something called the zero product property. The way the zero product property works is you take each factor and you set them equal to 0, or in this case, not equal to 0. So it turns out there are two numbers that x can't be. X cannot be 2, and it can't be negative 1, because both of those numbers will make the denominator 0. Now, we're also going to learn another format for writing these inequalities. They are called interval notation. For example, in interval notation, which you may or may not have seen last year, depending on your Algebra 2 teacher, the answer to B is this. What it says is that the x values start at negative 3. The reason for the bracket and not a parentheses is that it can equal negative 3. It's the equivalent of your closed circle on a number line. And then the second coordinate in what looks like an ordered pair but really isn't is infinity. The reason for that is because if you were to graph that inequality on a number line, you would start at negative 3 with a closed circle, and you would have an arrow going off to the right forever. And in mathematics, forever is the infinity symbol. X not equal to 4, I'm not sure if there's an interval notation for or not. It's not one that pops up that often, so I'm going to ignore it. The other one I'm going to look at is C. Notice that this one didn't have a line underneath. It was just x is greater than 1. So in interval notation, it would look like this. It says it starts at 1, except that it's not equal to 1 because we would use an open circle. And then the arrow goes off to the right. What would happen, though, if the arrow went off to the left? Well, in interval notation, for example, let's say I gave you x is less than 3. In interval notation, it would look like this. Notice the negative infinity. The reason for that is because if we graph that inequality on a number line, we would have an open circle at 3. That's why there's a parentheses. Except the arrow goes off to the left. That's why what's on the left is a negative infinity. The other thing we sometimes run across is this. This was called a compound inequality. It means that all the x values are between negative 4 and 3. It's just that it does not include 4, but it does include 3. The parentheses, again, is your equivalent to not equal to. Your open circle. Let me make that look like a better circle. And then the bracket is your equivalent of inclusive or closed circle. We'll run across that again, so don't worry so much about it, but I wanted to expose you to it now. These are the most important concepts coming out of section 1.1